Alright, looks like we're live. Hello everyone. I hope you are doing well. So, today we're going to be looking at, I believe the title is Voxel Rendering by 3D Texture. And it's a little bit ambiguous, but that's alright. But first I thought I would show you something. So I'm not sure if you guys noticed, but the program crashes sometimes, just after being open for a while. So I thought we'd try this technique here to see if we can get any more information. So the program's just crashed and it's going to say device lost. Okay, and this is our basically our assert function for Vulkan. So if this something fails for some reason, it'll basically get printed out here. And device lost is not very descriptive, so I want to see if we can step into here and have a look at what the result of this might be. So we got a count and some checkpoint data. And I need to add something else, I think, in this scope, because it looks like we just exited the scope and did not get the relevant information. That's unfortunate. Wrong file, there we go. So I'm going to add random stuff in here. It's debug, so this isn't going to get removed. Debug build, and so it's going to have more things to execute after that line, and the scope probably won't end. In the meantime, while we wait for it to crash, as you can see, we have projected the ray-marched 3D objects. We've got 3 spheres and a cube all here, which are not part of this voxel terrain. Also, the voxel terrain is now fixed. There was an issue with the order. I think it was in the shader. Yeah, let me have a look. What's the shader we're using for it? Cube shader. So if we look at the cube vertex shader, if I reorder it, the world position to Z, Y, X, we get the correct result. Which is a little bit strange. I noticed that they were correct in the vertical axis, so I thought, oh, they might just be out of order with the way that we've stored them. So yeah, that looks pretty good. Well, it's fine for 3D terrain. These things, well, I haven't combined the depth buffers of these two things, so they're just going to show up on top of everything, which is fine. But what we're going to work on today is basically, we're going to bring this back down. Oh, we got a crash. I think that's good. But it seems to have just frozen the program and not actually crashed in the debugger, which is not great. Did we get an error message? No. That's unfortunate. So what we're going to work on today is we're going to bring this back down to a single chunk, and we're going to try sending the chunk data in as a 3D texture. So right now we've got this. It's just a really simple, silly way to do it, where we've got a storage buffer. We send in float densities. So basically every chunk we're sending in all these 32-bit floats, and then we check if the density is... Actually, we don't even do it in this shader, we do it in the fragment shader, which means it's happening on every single pixel of the screen. We check if the density is less than 0.5, and then we discard it. Which is, fine, but I think we can do better. So the plan for today is we're going to send in a 3D texture. And a 3D texture is going to, let's just imagine this is a 3D texture here. I'm going to group this stuff together. Hopefully I can get all of the bits and pieces. Oh, we got a crash again. So let's see what we got. Device lost? Yes. The reason we're getting crashes, I think, I'm not 100% sure, I'm new to Vulkan, I think we have either synchronization issues, so we're doing all this stuff on the GPU with memory and things, but there's no wait period, so we're kind of updating pieces of memory and then there's race conditions happening. Or the other thing could be where overrunning buffers of some kind, so most likely just memory issues. I don't know exactly, but we'll see. Okay, I can't actually use this. Oh, it's a null function. Okay, so I need to suppose I need to run I need to request it. Provided by, okay, I see. So I was looking at the documentation. I need to request this extension, I believe. Okay. So it's got NV in it. Does that mean it's for NVIDIA? Or what does that mean? I don't know. Let's have a look at this. Oh no, I opened the spec. Oh no, this one's okay. Alright, let's have a look at this. So we got the device extension. So it's a device extension. It's not ratified. Okay. So Vulkan version 1.1 interacts with KHR synchronization 2, which I believe we are using. Alright, so it is an NVIDIA extension. That's fine. We are using an NVIDIA card on this machine. So if we look at required extensions, which is somewhere in this giant file, or validate extensions, available instance extension, it's a device extension, right? So where is that? SDL extensions, okay, that's fine. Device extensions, here we go. So required device extensions, we probably want to append to this. And we'll just use, what was it called again? Not that one. It's called VKNV device diagnostic checkpoints. Now, should I just put that in a string here, maybe? And that should be fine. Now, hopefully, when we build, now we can't build because I've got it open. And then we run. I didn't realize I was still so congested today. Man, this sucks. Not the end of the world. Well, hopefully now we actually have a function pointer that works. But can I have a look for that, maybe? Control-Shift-X, vk.get q, checkpoint, data, and v. Okay, vk is not defined. I guess I gotta wait until we get into this scope, huh? Alright. That's fine. It will crash soon. While I'm talking, probably. So I'm thinking, grab a 3D texture. And we can imagine this is an 8x8x8 or 16x16x16 area of voxels. Okay, and then in our 3D texture, we can actually put data in there. So if I put some lines here, I guess 6 lines would be appropriate. I don't know if I want to use that style. You know what? It doesn't matter. We just want to get the point across, right? Good enough. So you can imagine we've got, I'll do the vertical ones as well. And actually we can align them a little bit. There we go. And we'll just rotate this. Oh good, we got an error. Unfortunately, we got a memcopy error this time, which doesn't, there's no error from Vulkan, but basically it looks like this data pointer is incorrect, although it has the data in it, which is why I'm confused about this. So sometimes we get the memcopy one, sometimes we get the what's it called? The device lost one. So unfortunately, I'm going to leave that like that for now. And yeah, so we can imagine something like this. Okay, I'm not going to draw the other lines, but we've got an 8x8x8 area. And now at the moment, what we're doing is we're basically saying, well, we're going to just have 1 is a solid and 0 is a, is air or something like that. So we're going to start with this kind of model, but you can imagine a 3D texture is just, well, imagine a 2D texture. So these are pixels. But instead of having full RGBA, we just use 8 bits, and we just use the red channel. So we've got 8 bits per pixel. That saves us a lot of space, because right now we're sending in float 32s. Apparently also Vulkan and OpenGL, for that matter, are much faster at sampling textures, and especially 3D textures. The way they're laid out in memory allows them to do lookups of nearby texels. So texels, I finally figured out what that means, because I kept reading the word, but I never knew what it meant. It just means pixels, but they can also be 3D or 4D, I think. You can go up to higher dimensions, but it's just a pixel, basically. Just an element of a texture. Texture element. Texel, yeah. Simple, huh? We got the wrong error again, unfortunately. Okay, so we can actually sample texels near each other, apparently in 3D space, with a 3D texture, much quicker than if we had a linear array of, like a 1D array of numbers. Now, I'm not exactly sure how that works. I'm going to have to look into it at some point, but that sounds cool. And it sounds like something that would be good for us because, if we've got all these next to each other and we want to do something like, collision detection, then we probably want nearby blocks and things like that. If we want to do ray marching, which we're going to do later, we want to sample nearby things. That sounds good. So we're going to grab our 3D texture. We're going to upload it to the GPU. Okay. At the beginning, I suppose, at the beginning of the program, and then that's it. So we're not going to do anything crazy right now. We're just going to see if we can render a simple chunk using a 3D texture instead of a storage buffer. So that's it. So we'll just render it rasterized as we currently are doing. What did we get this time? Oh, nice. We got something. We couldn't submit the queue because did we get a different error message? Maybe we didn't get an error message. That's unfortunate. So basically we failed in the queue submit function, so it didn't return a result that we can check. That sucks. Well, it's okay. We've been really haphazard so far. With the code, there are like 8 pipelines. There's a bunch of stuff that we're doing every frame that we don't need to do. So I'm thinking what we'll do in this, actually I'm gonna, I haven't committed code for a while. Whoops. Let's have a look how much stuff we got in here. Yeah, not that much. Okay, but I did abstract a little bit, single time command stuff. So this is using a command buffer to just do commands like copying, for example, copying data to image, which we're going to use shortly. So I'll just say single use command buffer. I don't know why I'm capitalizing every word now. Abstraction and upload image, upload data to texture. That will be fine. All right, thank you. Now, I'm thinking what we're going to do is we're going to actually just comment out a lot of stuff. So we don't need like the default graphics pipeline, or even what are we rendering with that now? we were rendering a model with it before, right? The simple 3D pipeline, but we're not rendering that model, and we're not rendering any vertices with it. So I guess we'll just comment that out. So I'm going to comment out in the state up here in the context all the stuff that we're not going to use right now, and we're going to go back to a really simple code. I'm not going to delete it yet in case I get something wrong. So we'll do pipeline layout, graphics layer. We don't need that. Descriptor set, that's the default one. We don't need that. We don't need the depth buffer stuff because that's the default pipeline. We're not using the vertex buffer or this or the sun. We will keep the debug pipeline, which is the one that draws the little floating cubes and stuff. Depth debug image memory depth debug. Oh, this was for drawing the depth buffers on the screen when I was doing the sunlight calculation. We don't need debug storage buffer. We don't need sun depth debug UI. That's not something that I'm finishing anytime soon. We're not using the point clouds. We are using the cubes. We're not going to use the SDFs at the moment. And let's see how much stuff breaks if I just comment out all these things. A lot of things. So the vertex buffer, I'm just going to delete it. Don't need that. Don't need that. Don't need the index buffer. Debug UI, nope, not using that. Deleted. Depth buffer, not using that. Let's delete that. Sun's depth buffer, we're not using the sun anymore. There's no fonts at the moment. The swap chain does need to be created still, that's fine. Somehow we deleted all that stuff and we didn't remove any errors. Weird. We're not actually using the default pipeline anymore. Seems a bit strange, but that's how it is. We are using the debug pipeline though. So what is this? This is descriptor set for the depth sampler. Okay, well, we're not using that. We're not using this pipeline either. Or this one. Or this one. We're not using the point cloud pipeline. Unless I changed it. No, I didn't. I just copied it. We are using the cube pipeline, so I'll leave that there for now. Oh, I should mention something else. If any of you have been watching the streams, you might have noticed that I did this thing where I set the viewport to the negative height and then I offset the Y position, because in Vulkan the Y coordinate is flipped compared to OpenGL. Well, actually, I found a better way to do this, and it's actually to make a Vulkan correct perspective matrix using this function here. And do I have that video open? I'll try to find the video that explained it, which was really good. So now you don't have to do any weird flipping. I don't have to flip the Y coordinate in my shaders, and I'm not getting weird results all the time for stuff because the perspective projection is actually correct. So that's really useful. Yeah, just thought I would mention that because it was pretty good. I like that. I don't need this. Okay, so the SDF pipeline, we're going to delete this for now. Good. All right. Still got a lot of errors apparently. So we are still going to use noise to generate our texture, but we're not going to generate our voxels, but we're not going to put it into this uniform buffer or the storage buffer. In fact, actually, there's a little preview here. We're going to copy it to this image. So I'm going to just comment this out because we're not using it right now. I'm going to delete these. I suppose... yeah, we'll need a way to store the data. That's fine. We're not using the uniform data. What was I putting in there? I was putting in... Oh, actually, we might... No, we're not going to use that right now. We're just going to render one chunk. Okay, I'm not doing... What is this? This is the SDF uniform. We're not using that. The model view projection stuff. we can clean this up, I think. So let's go up here, grab these, go down here. This is the model, this is the view. I do like those names, but now that I have a much, I have a couple of days more experience, I think this is acceptable to just use the standard model view projection names. At least for my mind, it's fine. Oh, good. This is called proj, I think. Also, this is the wrong function. Oh no, that's what I called it. I didn't call it Vulkan perspective. That's fine. Okay, we have nothing to do with the sun anymore, so we can delete that. We're not going to move the sun. Isn't it nice to delete code? All this stuff was to do with moving the sun and the sun's projection plane, near plane and far plane. Don't need this. There's no sun position anymore, so I mean, I guess there still is one, but I'm going to delete it. So yeah, nope. This isn't going to do anything. I'm not currently using micro UI. I was testing it out and it was getting messed up, and I think it was because my projection matrix was all wrong. So I think I'll leave that there for now. We're not moving the sun. And camera position equals moving position. That should be fine. No more sun stuff. There we go. So this is just what we update every frame. That's fine, I guess. Time since start F32 is going to be start time. Okay, that's for like sending to the shader the current time so we can rotate things and move things based on the time or whatever, which is fine. Test light position, that's all good. Actually, we don't have lights because we're not using the default, so we don't need that. Okay, this device wait idle I didn't have here before. I think this has made it more stable. So it's sort of a, as far as I understand, it's a it's kind of a hacky way to make sure that you've got the you're waiting for, yeah, here we go, outstanding queue operations to be finished. But I think there could still be problems with the memory, the way the memory is updated and stuff. So we want to make sure that that stuff's all tightened up, because on failure, this command returns device lost. Yeah. So basically, we've got overlapping mapped memory, which apparently is not allowed. So that's one thing. So we're supposed to wait until, I think we're supposed to wait until the memory is updated each time. I need to look into that a little bit more. I'm going to just delete this anyway because we don't need it. Delete this, we don't need it. And also we don't need any of this stuff. Oh wait, no. This stuff's fine. I will delete these because we're not using them. This is the debug shapes. I don't know why it didn't fix me. But we do have a memory map here, so potentially memory sync issue. Yeah, we'll just delete this and this. Don't need that. Don't need any of these. Wait a second. Why? This is the same, right? Projection times view. Yeah. Whoops. So just going to delete those. We'll just use the standard push constants here. We don't have a depth buffer image, so we don't need to transition it. We will make one. Hang on a second. How was I rendering the chunks? Was it was in the cubes, right? Yeah, it was. They seem to have a depth buffer. Cube pipeline. Yeah, it's got a depth attachment. It's using depth buffer image view. Oh crap. I needed that one. It's using the normal depth buffer. Well, that's alright. I can grab it from the code in a second. We don't need this. But I do need, actually, I need that back. Depth buffer image, yeah. Alright, so I do need these. But I might actually just, I'll make it part of the cube. We'll make a new one, that's alright. Alright, so this is going to be cube depth buffer image, I guess. And what is this? Sun depth buffer image, we don't need that. Main render pass is, I hate this color. I've been looking at it for a while, I don't like it. Let's make it sort of a brighter blue. Something like that, a little bit brighter. Okay, well actually, I should just go down to the cube render pipeline here. Since we're not doing this, and we are doing the debug drawing. So, we don't need any of this stuff. I think, yep. And the clear value. So the thing about this is we don't have a begin rendering. Okay, so we do need the begin rendering. We don't need any of this stuff though. Okay, so debug drawing actually should come second, not first. And then SDF pipeline is going to be removed for now. Draw player POV depth buffer, we don't need that. We're not showing the depth buffers anymore, we don't need that. And we don't need this, and we don't need this. The cube depth buffer image is good. No debug UI anymore. I'm just deleting lines and lines and lines and lines of code. It's great. I think this stuff is all the same. And now I think we've deleted like 1,000 lines, which is nice. That's all good. That's all good. That's all kind of self-contained stuff. So we just need depth buffer image, image view, and memory, and we'll put that down here in the cube. Okay, we need to actually make those, which we'll soon. This is going to be cube depth buffer. Wait. Yeah, I suppose that's true. So begin rendering based on this render info. Let's have a look. What do we got? We're going to clear the screen using that color. We're going to use this depth buffer. We're going to clear it. And we're going to use this width and height. That's correct. We're going to use these attachments. That's fine. Cube depth attachment. So this doesn't exist yet. That's fine. And what is this? Cube push constants? No, it's just going to be push constants, I suppose. That's all good. We're going to render one chunk again. So wherever we've got probably multiplied by 8, multiplied by 8. It's probably going to be a few places here. There we go. So this is going to be chunk. No, we don't actually need this cube storage buffer. Yeah, so we're just going to delete it. The uniform, I think I will keep for now, because the idea is that that's going to hold the chunk coordinates that we're loading, and then the texture is going to be relative to those particular coordinates. So we need memory requirements here. It should be fine, I think. This should be chunk total. Actually, no, it shouldn't. That's the amount of chunks we're loading. We're just loading one chunk, so I'm going to leave it as a single vec4, which is just going to be zeros anyway, so it doesn't really matter. All right. So we don't need the storage buffer anymore. Uniform buffer can stay on binding 1, I guess. That doesn't really matter. But we are going to need something else, which is going to be a texture sampler, combined image sampler. That's going to be available in the fragment shader. Is that right? Let me have a look. Cube dot, but actually no. Yeah, I mean, I guess so. It's kind of weird doing it this way, now that I think about it. Because it means we're going to construct the vertices regardless, and then we're just going to not draw anything. I don't know if that's wasteful or what. That's okay. So that's going to be the image sampler, which is going to be in the fragment shader. That's fine. We need to actually make it, which I'll do in just a second. I'll be right back. Alright, sorry about that. I wasn't gonna get another coffee, and then I decided to get another coffee, so I did everything in the most inefficient order. So where were we? We need a depth map for our or depth buffer for our cube rendering. However, we also need this image, which we're going to make. So sampler, I'm pretty sure I made a sampler before, although I may have just deleted the code. Copy data to image, SDF sampler, not that one. Alright, I guess I deleted it. That's fine. So, the cube uniform buffer, that's still a thing. This is going to be sampler. I think it's actually called something else. Yeah, we want combined image sampler. It's not a buffer. So we're going to delete that, and we're going to put p image info sampler equals cube. I don't think I made this yet, right? Oh, I got a new hotkey that I need to start using. So space and then S gives you the symbols in the file. Space and Shift S gives you the symbols in the project. So you can do space S and then the struct name or whatever. You can go straight to the struct definition. Or the function, let's say copy data to image, for example. It's pretty cool. I like it. Reminds me of C tags back in the day. So, we've got the depth buffer image. We're kind of doing two things at once here. We've also got, I need these three things for the voxel data. And I'll call it that, I guess. All right. So this is for the voxel data. That's not the sampler though. What is this again? I think this is a different type. Sampler equals, no. Sampler is a sampler. Okay. Cube, voxel. Actually, what did I don't think I made one. I don't think I defined one up here, I mean. Sampler. There we go. Alright, okay, thank you. Let's go back down, please. There we go. Alright. Image view. Cube, voxel, data, image view. Image layout. Cube, voxel, data, image, layout. I think that's everything we need. Apparently I got something wrong. I need to actually do this. Take the pointer to a descriptor, image info. That's misspelled, and also there is no image layout. Huh. Do we store image layout on here? I would have done it here. No. Huh. Feel like this is going to be local variable. Is that right? Because we make the image layout here. Alright, I'll just store it. Who cares? Yes, thank you. Alright. So we've got depth buffer, which would be the cube depth buffer, I guess. Which we still need to make. Okay. Lots of things to do. I'm just going to open up on the other screen my GitHub, which has all of the code. Actually, I can probably just check here. We had depth buffer. Here it is. I guess I'll just grab this. Although it's going to be kind of messed up. Let's see. So if we search for start of line and then a dash, we can just delete that. There we go. That's fine. Okay, now we go down a bit. We need this part here. This is creating the image view. Okay. Maybe this could be abstracted. Let me see. It might be time to make a few functions. I've got a couple, but I don't like the amount of copy paste with the same things. Alright, so I think what we could do is maybe grab this, go to the bottom. I'm going to make a VK create image. Well, the thing is, if I just put this code in here, this creates an image and an image view and allocates the memory, which is fine. I guess we always want those things. So, oh no, it's got spaces. Disgusting. That's better. What's up with this? Oh yeah, right, okay. Doesn't really matter right now, but let's see. So the idea is we can create an image. We have a few things that we might want to change for different images, for example. They might have a different size. So that would be this. And they might have a different depth. They might have a different format, a different dimension count, different MIP levels, different array layers, probably not different samples, and different usage, and different sharing mode. Okay, so maybe I just pass in one of these, huh? Okay, and then we also pass in a view create info. This is fine abstraction for now, I think. Image view create info. I made a typo over there. There it is. Okay, and we get back a VK image and a VK image view, and we also need to take in somewhere to store the memory, or maybe we actually send that back as well. So we also get back a memory location, so that would be a vk.device memory. I guess I should give these names. Image view memory, or maybe just view, image view and memory. That's good. And I guess if we're passing in these entire structs, then we don't need to use them. Should we just pass in the context, or yeah, we'll just pass in the context by pointer. That way we have access to the device, to the GPU, and other things that we may or may not need. It's actually only those two, but I think. So here what we want to do is we want to store this inside image. Right? So we use the image create info that we pass in. Store this in image. What's the problem here? We can't pass a pointer. We need to copy these. Okay. Image create info, or we could pass them by pointer. I guess we can pass them by pointer. Might be I don't know. This is a fine for a first approximation. So here we would use image. That's fine. Memory requirements is okay. That's all good. Is that always correct? Device local? No. I don't think so. Because we might want to update the texture data from the CPU. So we're going to need some memory usage, I guess. What is that field? It's memory property flags, okay. I'll call it properties, I guess. Okay, and now this can be the memory. Very good. This can be, actually that can't be a pointer, right? Oh no, it can't. This is an out parameter. This is a return parameter, not an out parameter. There's nothing called image, that's fine. This is just memory. Good. This is going to be image. Okay. Actually, we're not even going to use this. We're going to pass this in. It's going to be called view info. No, view create info, I think, isn't it? Image view create info. This is going to be image view. Or just call it view, actually. And that's really bothering me now. These things are not aligned correctly. Okay. Return image view. Actually, I just have to call return. I don't have to do that. It'll just return these things. That's good, I think. So unfortunately, I just deleted the create info that I was going to use. Let me grab this. Where is it? Here. And how do I copy it to a different buffer? Copy or yank? Yeah, I can never remember how to do this. There's a way that you can use a different clipboard, and I keep thinking that I'm gonna use it more, and then I just forget. Well, what if I just, okay, I'll just copy this, and then I can join this copy. Alright, that'll do, and then we'll just go forward. And what if I do this? Oh, that didn't work. Interesting. Fine. It's all good. Alright, so... Oh, we actually had we still have it up here. Okay, that's fine. So what we're going to do up here is we're going to call vk create image, and we're going to pass in the context. we're going to pass in our image create info, which is right here. I suppose I can just do this. Oops. Okay. We also need image view create info. And properties. So we're going to say host visible, host coherent. All right. Oh, actually, this is for the depth buffer. So I guess we'll make the depth buffer device local, and then we'll make the other image as well. So there's no. Oh, this is interesting. Yeah. So that's a bit of a problem, isn't it? Maybe not. But what I would want is for the image view create info dot image to be image, right? So then we don't actually need to pass in this here because we're not going to have access to it yet, I guess. We can probably do some stuff like, it doesn't matter. This is fine. We'll pass that as a pointer. Alright, and what we get back from this is going to be depth image, depth view, depth memory. Actually, we can just assign them directly here. pk context.cube depth image. Alright, we should be able to assign all of these. So there's image and image view and memory. Alright, that's a very long line. That's alright. I don't know if we can put these on multiple lines. I guess so. Okay, good. Now, we have no errors, but this doesn't mean the program is going to run. In fact, I'm quite sure it's going to fail if I try to run it. Look at that. So, what happened this time? Descriptor sets are not matching. That makes sense. We didn't actually add the... okay. The image sampler. Null descriptor is not enabled yet. There's a few things we need to do first. So I guess we create... Why is that? Ah, god damn it. It's not aligned. The LSP doesn't support partial alignment, partial formatting. You've got to either format the whole file or nothing, apparently. Which is a bit annoying, because I don't want to format the whole file. Oh, this is interesting. Oh, this should go back. There we go. That's good, I think. So we had the descriptor sets, which were not correct. Why? We got combined image sample in the fragment buffer and uniform buffer in the vertex buffer. Could have something to do with the shaders. So we're not, what are we doing again? So uniform buffer is number 1 and combined image sampler is number 0. So yeah, this is not going to be a thing. This is going to be actually a uniform sampler 3D. And we'll call this voxels, I guess. And we don't need that. And actually, it's not even going to be in the vertex shader. It's going to be in the fragment shader. Density is undeclared, right? Yes, of course. So this is not going to be a thing. That's fine. Actually, I think it makes sense to sample it in the voxel shader, not the fragment shader. So otherwise, we're sampling it for every pixel. Whereas if we sample it for the vertex shader, we can sample it for each vertex, send it to the fragment shader as a variable like density or something. And then, yeah, okay, we'll try this first, and we'll see which one is more performant, I guess. All right, so what was the problem? That time I didn't actually read it. Let's see. Okay, let's look at the descriptor issue. Because the image view is null. Gotcha. Okay. So that would be the image view here. Cube voxel data image view. I thought we were updating that. Oh no, that was the depth buffer. Yeah, so we need to make this other image here, which is going to be the 3D one. Create image. Actually, I don't like the name. Doesn't matter right now. Context. Okay, so we're going to send in another create info. Just going to copy this actually and just rename it, but it's going to be different type. And instead of depth, we're going to put in voxel. And actually, instead of buffer, it's data. The type is D3. Format is R8 unorm. So we're going to send 8-bit integers between the value of 0 and 255. We could use snorm actually. And I'll show you why that's going to be cool later, hopefully. I8 snorm. It's D3. It's no stencil attachment. It's going to be sampled, yes. And the other thing is transfer destination. Yeah, because we're going to have to set up a an annoying thing where you got to set up a buffer and then copy the data to the buffer and then transfer that data to the texture. Well, I find it annoying anyway. What is this? Aspect mask? Color, I guess. What's wrong with this? Voxel? Oh yeah. This is depth. Actually, depth is going to be 16. These are both going to be 16. Or actually, maybe more accurately, it should be chunk width, chunk height, and chunk depth. Okay. That looks fine. I'm not going to do MIP levels yet. Maybe that will be something later. It's not going to be device local. It's going to be host visible, host coherent. Actually, yeah, because we need to copy the data to it, right? So I think we need that. Alright, I think that should get us a little bit closer. We failed finding a memory type. We failed creating an image for this, apparently. What's the error if we got one? Failed to find suitable memory type. Okay, that's not great. Now, why is that? Is snorm not supported, maybe? I know r8unorm is on my computer. No, that's not the problem. Well, guessing is not really useful. So failed to find memory requirements. Okay. Well, let's have a look here. Can I search for what is it called? Find memory type. What? I don't want a log file. I want to search for vk find memory type. What is this for? This is for... I'm searching for this because I actually did make a 3D texture and I did load it in. It's probably still here in this render doc from yesterday. It's not that one. No, not that one. Well, maybe it's not in this render doc, but I did do it at some point. That's alright. Nope. But I just wanted to clean up all of that junk that we got, that we had. There was like over 1,000 lines of junk that we're not using. Hang on a second. That's not finding the next. Is it? Oh, it is. What is this? Uniform buffer for the sun. This is for the debug storage buffer. We don't need that one. Point cloud uniform. You know what? I should search for actually D3. Because there was only one. Here it is. Oh, that's what I've got right now. Nah, that's not what I wanted. Here it is. 3D, SGF 3D texture for voxel data. I was doing 8x8x8. That's fine. Transfer destination sampled. Is that the problem? Maybe. Did I use transfer source? No. I used transfer destination as I thought. So r8unorm D3. Oh, I didn't make the sampler yet. Maybe I need to do this part, right? Device local. Hang on. Allocate memory for... For what? For the sampler image. Device local. Oh. I must be confused about how that works. Maybe you make a device local image and then... But how do you update data to it? I mean, I used a transfer buffer. Maybe that allows you to send data to a device local storage. Okay. Well, let's see if that was a problem. Oh. I think that was a problem. What have we got now? All right, so descriptor update. The combined image sampler is being updated with invalid image layout. Image layout undefined. So in the image view, allowed layouts are read-only optimal shader. Oh, did I leave it as undefined? It's not this, right? No, it's not this. It's, where is it? It's here. So it's saying the image layout. Oh, we're not setting this anywhere. Interesting. Oh, yeah. Because I remember saying something like, oh, I think we create this elsewhere. Right, what is this? Transition image layout. Oh, yeah, I'm silly. This is not, this should be, as I was saying, not undefined. It should be transfer destination, I think. Yeah. So that image layout thing that I was storing, that's why I wasn't storing it, because it's not something you store, it's an enum. Okay, what do we got now? Okay, allowed layouts are read-only optimal, layout attachment optimal. Right. The transfer destination is not allowed. It is going to be shader read-only, so I'll put it on that. It's just I think we've got to transition it to something else. Shader read-only. Alright, and now we have another error, which is attempted to write update to sampler descriptor with invalid sample. So the sampler is currently nil, because we didn't make one yet. And pretty sure I made one in the old code, so let's have a look. Git diff. Create sampler. Whoa, what has happened? Okay. There it is. Oh yeah, it's this call, right. I guess I will put it here. I suppose that clamp to border is fine. We don't want linear though, we want nearest. Sure, float opaque white doesn't, I don't think that actually matters. So this is going to be not the depth sampler. This is going to be context.cube voxel data sampler. All right. Oh, more errors this time. Good. All right, it's invalid to call this inside. So begin rendering, it's invalid to call this inside an active render pass. Right, so I must have begun rendering and not ended rendering. Let's have a look at that. Begin rendering and begin rendering. But there's no end rendering. Yeah. Okay, so let's grab this. Let's put this here. Actually, this should be... What the hell? Oh. No, down here. Oh no, begin. I've got two rendering infos here. Okay, what's this? Cube pipeline. Okay. That looks good. So why don't we just delete this one? I think. Wait. Yeah, oh no, this one's wrong. We don't want this. I suppose we'll put it here. Alright, that should be fine, I think. Okay. So command draw must be called inside an active render pass, which means we do not have an active render pass. So we've begun rendering. Find a pipeline. Do stuff. End rendering. Okay. Right, now we need to begin rendering again. Wait, I shouldn't have ended rendering here. Alright, now at least we have a blue screen. Oh, look, we got debug shapes. Okay. Some semblance of normalcy is back. There's a lot of errors over here, which is fine. Now let's have a look. I will just pause this. Alright, let's have a look. So we got command draw, none. Dynamic scissors are used by the pipeline state object, but were not provided via calls cmd set scissor. Yeah, okay. So we're gonna just say this must be for this pipeline, right? Cube graphics pipeline. It's only got depth test enabled. That's it. So maybe it's for the debug pipeline. Yeah, I'm just gonna get rid of this. I don't want. Why is that there twice? Any of this stuff except depth test to be dynamic. I don't like this dynamic stuff right now. I mean, it's cool, but I just don't want to write all the extra code. So we'll just get rid of that. And that means we've got to put in here, in the pipeline, creation code, a viewport, and scissor, and the other stuff. But I think it has the other stuff. So it's got topology, it's got rasterization, depth sensor color blend. Alright, that's all fine. We'll just add this. That's correct, I think. Still got a couple of errors here. Alright, so vertex binding 0 is null. Okay. That's fine. We're not using vertex buffers, so maybe I'll have a look at that in a second. The other thing is, what is this? So we've got the image barrier. So cannot transition the layout of aspect equals 2, blah, 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 from shader read only optimal when the previous known layout is depth stencil attachment optimal. Vulkan spec states if the source queue family index and destination queue family index define a queue family ownership transfer or old layout and new layout define an image layout transition, or layout must be undefined or the current layout. Yeah. All right, so that's happening in our transition, I think it's called. So we're transitioning, it's probably this one, right? Is it the cube depth? Well, we're also doing this one. Transition from shader read only to depth stencil attachment. I guess this is because I was drawing it on the screen before. Because we're not, I don't think we need to do that. So I'm not drawing it on the screen anymore, right? So I don't need to transition it. Now we've got vertex binding 0 is null. Most likely you forgot to call bind vertex buffers. If the null descriptor feature is not enabled, all vertex input bindings must be declared in the vertex shader's entry point, must not be null. Okay. Okay, so I don't think we're using the vertex buffers for anything, which means anywhere that we've got vertex buffers, which doesn't look like we even have defined any vertex buffers. Oh, here we do. What is this? The debug pipeline has a vertex buffer. No, we don't need that. We just need to know how many we're drawing. Alright, good. So that was just working before, but it was actually a bug. Alright, no bugs. We're drawing stuff on the screen. Excellent. If we have a look at our stats, we've decreased the code by 1,720 lines and added 256. I would say that's a pretty good decrease in code. Now, we apparently have a texture. Let's see if it's going to be anywhere in the pipeline. I don't know because we're not using it. But no, I can't run this in RenderDoc, which means there is actually something wrong with the code. So when RenderDoc's trying to hook in, it's encountering an error. I think it's going to be something to do with the texture. So what we've got here is a device local. Yep, 2 device local textures. We don't have any data in the textures. Going to be a problem? I don't think so. Okay, let's just try to get to the state of adding data. So I got this function that I wrote yesterday. Here it is. So copy data to image. Now I think we need to actually run a fence or something in here. So we've got qsubmit, qwait. Oh no, we do have qwait idle here. So I think that should work. We'll see. So we're going to use this function here, vk copy data to image. And I've got it commented out here. But basically we're going to copy in chunk total amount of unsigned 8-bit integers into our cube voxel data sampler. Actually, wait, what do we put this into? This is the image. The image, and it's going to be 8 by 8 by, or 16 by 16 by 16 rather. And we're going to use this scalar field data, which I haven't allocated. It's technically not a scalar field. Well, I guess it is a scalar field. It's a field of scalar values, but just going to say our noise value is here, and then that's all good. So generate the scalar field, put the data into this texture, and then hopefully we can do something, but apparently we got an error here. What is it? Index 4096 is out of range. That's fair. You know, because this should not be in here. This should actually be... Actually, I'll just define these as 0. This code is a bit messy now. And this is... Let's see. Right, so we've got memory invalid. So we've got a null device memory, which means we didn't allocate the memory for our image, which is a bit of a problem. So we're using VK map memory. I wish that I could see where the line was in our code. Unless I'm mistaken, I can't get that. It would be really handy to see which map memory it is, but that's all right. So if we look for map memory, there's actually only 2 places, and this one was working, right? So it's going to be this one. Okay, so we've got this staging buffer memory that I guess we didn't create because I deleted the code. So we need to make this. My idea is we're going to just make a big buffer that anytime we need to copy something to a texture, we just use this one. I think that will work. And so if we look here at the diff, find staging buffer, and we'll go to the next one. Here we go. Yeah, so basically I want to make something like this. So we can just do that up here somewhere in our initialization code. After we initialize Vulkan, obviously. After we initialize the swap chain and everything, perhaps. Create arbitrary command buffer. So maybe around here. Create staging general purpose staging buffer. Right. Now we can select these minus signs, delete those. Very good. Oh, there's also a plus sign here. So we probably want to get rid of that. So we've got a staging buffer. We're going to use these memory requirements, which is not going to work. There we go. It's going to be a storage buffer that we're going to transfer from. It needs to be host visible and host coherent, so we can transfer data into it from the CPU. And its size is going to be, I've just put this number, but let's say, I don't know, let's just say, what is that number? Let's see, 128 by 128 by 128, 2 million bytes. I suppose that's fine. We can adjust that as needed. Now, do we get a running program? We do. Can we run it in RenderDoc now that we're actually allocating the memory? No, there's something else wrong. That's unfortunate. What I can do is run the program, and we'll put in a breakpoint at some stage. I'll just put it down here somewhere. Bam. Now let's have a look at the Vulkan context. There's a lot of stuff in here. I can't. How is it VK context? And maybe some of them is a nil, but they need to be, you know, not nil. Like the cube storage buffer, for example. Actually, we're not using that anymore. Graphics Q index is 0. That's fine. Swap chain format. That's all good. It's going to be something to do with the new things, I think. These all look like they got correct. You know, they all got IDs, right? So we've got the cube storage buffers, they're all zeros. Maybe that's a problem. I need to look at the code, and the uniform buffer size is only 16, which is fine. I think that's just one vec4, right? Which is what we said. Everything else looks good, I think. So let's look at this storage buffer. Cube storage buffer. Well, we're not even using this anywhere, so I'm just going to comment it out. Okay, program is running, no Vulkan errors. But also, it's probably not going to run in here, right? Yeah, failed to get device extensions. Ah, well, that's a bit of a problem. So actually, we're running into this. It's probably this NVIDIA device diagnostic checkpoints. So maybe I'll just get rid of this for now. I'll comment it out because it might be useful later. Right, okay, so that was a problem. Luckily, the terminal actually showed up above the window, so I saw the error for a second. Alright, capture a frame. Now we can have a look at our color paths. We've got two drawers. The first one is going to be the chunks. The second one is the debug shapes. So if we have a look at this, we should see, hopefully, no. We don't have any, oh no, that's fine. We don't have chunk data. It looks like, yeah, that's fine. That one doesn't matter. I want to see the depth, no, not the depth attachment, the sampler. It doesn't seem like it's here, maybe because we're not actually using it, so it's getting compiled out. All right. Cube.frag.glsl. So we got this sampler for voxels. What if I say texture voxels vec 20? Is that actually, it's got to be vec3.r? Is that even gonna compile? Let's have a look. Apparently. Oh, I don't actually know what that's doing because we're not drawing anything, but now that we're using it, we might be able to see it in RenderDoc. That was the point. Okay, fragment shader, we've got the 3D image, here it is. So if we have a look at the 3D image, it's actually tiny, it's only 16 pixels. But we can look at the, actually we can look at the, where is it, slices? So you can sort of go through each slice of the 3D image. It looks like it's just black. It's black only. So what that is telling me is that our loading of the image data is not working. So is it the scalar field? Is there a problem with this data? Because we're setting it to either fully red or black, and it's all black for some reason. So let's see, shall we? I'm gonna add a breakpoint at line 1201. Where is it? Yep. I'm gonna run this, I'm gonna have a look at the scalar field dot data, I guess, and that will be an array of let's just say 512. Okay, so I've got, you know, a lot of black and then one red and then black, 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 red, or empty and full, whatever you want to say. Yeah, so this is fine. We got the data in the CPU side, right? But it looks like it's not getting put into this image. So let's have a look. F11, there we go. So I'm mapping the destination, which is based on the staging buffer. So we're going to copy everything to this staging buffer first. And if we have a look at the context.staging, actually I can just look at this. Yeah, staging buffer size is that 2 million size, so definitely enough space. Right, and then we copy. That seems to work. Actually, I can just look at this as an array, I think. And we should see the same data in here. Yeah, so we've just changed this. It's just been updated. That's why it's red. All right. And now we begin single time commands. We create a barrier. The old layout is undefined. The new layout is transfer destination. So we're going to create a barrier, top of pipe transfer. I think that should be fine. So actually calling it layer level count is 1, layer count is 1. Is that right? I think so. And then we copy the buffer to the image. And you know what I didn't do? I didn't wrap these in vk must. So this return a result. This one doesn't. What about this one? It also doesn't. Maybe that's why I didn't do it. That's weird. So how are you meant to know if they succeed? Whoops. Yeah, there's no return type for any of these. That's unfortunate. Old layout is transfer destination. New layout is going to be shader read only. That's correct. The access mask is transfer right. And destination access shader read. Okay. So we're going to change it in the fragment shader. Should that be fragment shader? Yeah, okay. What other options are there? Alright, there's tests. Yeah, early fragment tests. So we want it by the time we get to the fragment shader. So that's what this is supposed to do. And this function ends the command buffer, submits the queue, and waits until it's finished. So that should work. I mean, I had it working yesterday with a different texture. So I'm a little bit unsure as to the issue here. Now, is this incorrect? I don't know. We're sampling the voxels. Obviously, this should be a lowercase v, and I should be ostracized from society for even suggesting that it would be uppercase, but, you know, it happens sometimes. The indensity is not even really a thing. So I'm just going to not check that anymore, and then we'll go to the cube vertex shader. Where is it? Yeah, we're going to get rid of this for now. Oh yeah, obviously I can't. Undeclared identifier in the fragment shader. Oh. Right, yeah, so this should be, let's just say 001, that's fine. I can't build because the program is open. Oh, I should look at my building. Am I building the right shaders? Yeah, I'm building SDF and Cube. So I actually changed my build script to build just specific shaders because I was building like 20 of them and it was taking too long. So now we're just going to build the cube shaders only, because if I look at my shaders here, .spv, actually I'll build the debug ones as well, I guess, just in case I change them and I forget about that. Whoops. So we'll just copy this and we'll build the debug as well. Debug and debug. Yeah, that should be fine. Doesn't take too much longer. It's a fraction of a second. So the thing is, whoops, what happened? I opened RAD-dbg. Oh, yo. What is that? Is that a big black box? Because we're drawing the cubes? What is going on here? That's insane. Interesting. So yeah, we're just drawing wherever there is cubes, I guess. Which makes sense now that I think about it. Wherever there could be cubes, rather. So it's just going to be black. Because I'm not discarding it anymore. So really what we should say is something like if... Actually, you know what? We could just do this. Texture and... Well, no. I think discarding is cheaper, but we're doing an if. Is if cheaper than multiplying something by 0? Vector 0 dot r, and now we probably won't see anything, right? Oh no, apparently we are seeing stuff. Oh, because I'm just sampling the first voxel. The first voxel's red value, but I don't know what that actually is. Also, did that even compile? Apparently it did. I don't know why I'm running it again. We didn't change anything. So that's going to be our chunk size, right? That's all well and good. However, I need to see why we're not getting the correct data in here. Is there something wrong with our image view? We're using S-norm instead of U-norm. That could be a problem. I said it was going to be cool, but maybe it's not cool. I should probably open this in RenderDoc, not the debugger. Alright, so let's have a look here. We'll just look at the 3D image, view the contents. Oh, look at that. It's got data. Yeah, I was probably messing it up by using S-norm. Because 255 is out of the range, and I don't know if it would have wrapped. Probably not. It's probably undefined behavior. So anyway, this is interesting. Now you can see if this is like we're looking at the chunk from the front, we've got this sort of slope. And then if we go down to the next slice, you can see it's a little bit different. Next slice. So this is sort of kind of curving in like this. I'm trying to do it from your angle. Yeah, that's cool. All right, this is great. This is good. This is what we want. And if we run this, we will see a giant black box because I haven't actually done anything with this data. But we need to figure out which voxel we're currently drawing. Which, how the hell do we do that? Maybe I didn't think this through properly. Well, we do it here, right? So I got the X, Y, and the Z, which means we've got the index. Not that index. Local index. Here. So if we send in local index, actually let's call it voxel index, because I think that would be fine. Right, and then we send Send that out here. It's going to be a flat integer. We'll use location 0 because we're not using that right now. Voxel index, and if we say we want to sample, actually maybe we should send the x, y, and z coordinates instead, because then we don't have to convert it back, and we can send it as an ivec3, and we'll say that's voxel coordinates ivec3 in voxel coords. I think, yeah. You can sample, I think you can sample with an ivec3. Let's have a look. Vulkan GLSL texture function. It takes a sample of 2D. What? Oh, look, I already looked this stuff up. Best way for textures in shaders? No. I want sampler 3D. Why would you think I would want to remove the specific 3D part of my query? How can I read 3D image with R8 uint format? That's pretty similar to what I'm doing. And sampled image descriptor in GLSL. Yeah, okay. It means you want to employ the capabilities of samplers. You want to access pixels via normalized coordinates, or you want to do filtering. You don't use a sampled image because you want read-only access to be faster. That's why storage images have read-only layout qualifier. If all you want is to have read-only access to a single bitmap level of an image using integer texel coordinates with no filtering or wrapping, then what you want is a storage image. Oh. However, if you do want a sampled image, okay, but sounds actually like I want a storage image and not a sampled image, according to this person on Stack Overflow, which as a rule I don't trust too much, but let's see. Storage image, is this a thing? Huh? This doesn't seem like it's a real thing. Images are other storage types. Okay. An image view is a wrapper that holds information about how to interpret the data. That's right. The sampler holds the data for the specific shader access. And it holds information about how to blend the pixels, how to do mip mapping. Samples are used in with image views and descriptors. Samplers hold exactly how the texture is accessed. They control filtering. You don't create samplers connected to a texture as they are standalone. In Engine, it's quite common to cache the sampler objects in a hash map and allocate them as needed. When you bind textures, there are different ways. We'll be using combined image sampler. Let's see. I'll go back to the code in main. If we have a look at the Vulkan code here, what have we got? We've got uniform texel buffer, or a storage texel buffer. Is maybe this what the guy's talking about? Maybe we want this. Because we're not really using the image part of it at all. Maybe he's onto something there. So let's see. Uniform texel buffer. Yeah, I wish the Vulkan website would just be better. Uniform. This one's pretty good actually, the documentation one, which I think is funnily called the Vulkan documentation project. Like, it's a whole separate project, which is interesting. Uniform texel buffer associated with a buffer resource via a buffer view that image sampling operations can be performed on. Ooh. I think this is actually what we want. So image view operations are these things: image fetch, texture coordinate systems. These are all operations. Okay, I don't actually, I mean, maybe in the future, but right now I don't want to read the about the bytecode particularly. Texture coordinate system for linear filtering. Okay. Buffers represent linear arrays of data. Yeah. So it said it can be used with a buffer resource, with a buffer view. Uniform texel buffers define a tightly packed one-dimensional linear array of texels, with texels going through format conversion when read in a shader in the same way as they are for an image. Load operations from uniform texel buffers are supported in all shader stages for buffer view formats, which report format features support for this particular flag. Storage buffer, storage texel buffer is the same kind of thing, but I think they're bigger. Let's have a look. There you have it. Oh, atomic operations are supported on storage texel buffers. I don't know if we're going to need that. Maybe in the future. I wish there was... Oh, here we go. There is a note here. On some implementations, it may be more efficient to sample from an image using a combination of sampler and sampled image that is stored together in the descriptor set in a combined descriptor. So that's what we're using. Okay. Yeah, okay. I don't really think... maybe this is going to be more of an optimization thing, and I just shouldn't listen to this guy right now. But what I actually want to know is if the texture function is the right one. Is there like a functions GLSL? Maybe I need to look on the GLSL website. GLSL docs, is that a thing? Basics, shading language, grammar. I want built-in functions. Here we go. So I'm looking for texture. All right, this is a 2D. I want a sampler 3D. Okay, so we can get texture size is supported. Texture query LOD. Okay, returns the mipmap arrays that would be accessed. Returns the computer level of detail relative to the... okay, querying the level of detail. I don't want that. Oh, look. Texture. There's an overloaded version with a sampler and a 3D Vec3 float bias. What does that mean? Not sure. But that's good. So yes, that is a correct function that I wrote there. Well, this is correct. I think actually it needs to be a Vec3. So I'm just going to say this is a Vec3 of voxel coordinates, and we're going to look that up here. Okay, and then that's going to be the green component, which is a little bit strange, but that's fine. Okay, and will that get converted into a float? I think so. But it's going to return a Vec4. So, oh, and I'm actually just using the red value. Okay, gotcha. So that'll return 1 if there's a 255 in there. I'm pretty sure that's what that means. I hope so anyway. So let's have a look. Out frag out voxel coords we're going to use equals vec3 x, y, z. Okay, yeah, that'll just be a vec3, and we'll build this, and we'll run it, and oh, that's not a great sign. They're all green except for this one, which is probably only black because there's another cube inside of it. And if I go inside, it's all green. Okay. That's telling me that this is not the correct coordinates, perhaps. See, the thing is, if the position works, you would expect that the coordinates would be correct. Otherwise, the cubes would all be on top of each other, right? So if I change this to a vec3 at the 0 position, it's just going to be one cube, right? Yes. And because it's just one cube, that kind of verifies that these x, y, and z coordinates are in fact being offset in 3D space. However, when I look up this, I don't know why I'm converting it to a vec3 value in the voxels, I'm just getting green always, I think. Can I test this somehow? I mean, an easy way to test this would be to make the alpha channel and then everything else is white. So I'm probably going to get a big white box. Yep. Even that corner down there. Okay. All of the voxels are filled in. And we know that's not correct because if we look at this here, F12, and if we look at the texture, again, resource 3D image, view contents, you can see we've got that slope. It's the same as before. So already we know this is not correct. So it's returning all of the values as filled in when in fact a lot of them should be zeros. So we can actually look at it in code here or in a raw buffer view. We've got, see, red, black, red, black, red, black. So we should be getting a bunch of zero values, but for some reason we're not. Why is that? Has it got something to do with the way this is being sampled? I mean, probably. If we look at the 0th element here, it's a 0, right? So if we put in a vec3 0, are we going to get nothing? No, we get a big white cube, which doesn't make sense. What if I sample a different channel? This should be broken. Big white cube. So it's always coming back as 1. Just a second, I need to pee again. Apparently I have the bladder of a 90-year-old or something. Oops, not this one. Went to a weird default scene. Okay, so I should have deleted that chat ages ago. I forgot chat's on the screen now. I fixed it. Oh, I'm not even on Twitch right now. Yeah. If I delete it, will it get removed? Let's see. I mean, removed from the overview. Yeah. All right. So I had a little bit of an idea. Instead of setting the out color to one random value, we're going to actually set it to the sample of voxels at the coordinates, and just see what that does, if anything. It's probably just going to be a big, oh, it's a big red box now, because the red is always 1, apparently. But we can see it. Oh yeah, I don't have blending on, so alpha doesn't matter. Doesn't matter what we set the alpha to. I should turn blending on. That might be useful. So we basically want to grab, yeah, additive is fine. I suppose something like this, color blend attachment. And then, yeah, okay. I'm just going to grab this. Actually, what do I usually use? 1 minus source alpha. I usually use this one. So that would be in the color attachment for the cube pipeline, right? Oh, no, before the, yes. Hang on a second. There is color blend. Color right mask, blend enable. Oh, I just never turned it on. True. This blend factor is going to be, source color blend factor is going to be source alpha. And destination is going to be 1 minus source alpha, yeah. 1 minus source alpha. And color blend op is going to be add. I think that's right. So let's have a look at what this does, because I wrote this a while ago. Right. Okay, is that going to work without the other fields filled out? Let's see. No. So we need also probably these fields. Source alpha blend factor, alpha blend op, and destination alpha blend factor, because we don't have those. That would be up here, blend config. Okay. So these all need to be filled out. There's no defaults for them, which I guess is fine. So it's going to be source alpha blend factor is vk dot it's not actually that type. What is the type? Where do I find that? I guess it would be down here. Yeah, source alpha blend factor is a blend factor. Okay. Destination alpha blend factor. Huh. Okay, an alpha blend op. Alright, almost done, hopefully. Destination and alpha blend op. Okay, 3 problems. There's no field name source alpha blend factor because this should be in color blend. Good. So we actually do need to fill these in though. So I will search for this, and we got source alpha blend factor is going to be what? 1 and then 0. Okay. For the destination. And the op is add. Okay. Hopefully that's enough to get blending working. I don't know for sure that it's not working until I try to change the opacity here to 0.5. Okay, it is working now, it seems. Kind of. I guess that's, no, I guess that is working. Yeah. Okay, so the problem that we're going to have now is why are all the values 1? I guess this should be RGB. So if we do red on the red and then 0 and 0 and 0.5, it still thinks that every single voxel is filled in, which is totally incorrect. I'm going to ask one of the AIs if they can tell me. Why is my Vulkan shader always sampling 1 despite the 3D texture having a combination of black and red pixels? Actually, I'll just send it this whole thing here. And let's see if it can answer any questions today. Okay, the texture coordinate range. Oh, it's got to be normalized between 0 and 1. Oh. Okay, well that sounds like an answer. So I got to divide by 16. Okay. Well, I didn't know that had to be normalized. That makes sense. So should I just... I guess I'll divide by 16 because... Something in my mouth. Well, now they're all black. Just not... I'm doing integer divide, aren't I? I need to do a floating point divide, I think. Also, I should divide by chunk width, height, and depth, which are integers. Well, that shouldn't matter. Integer divide should be fine. No, it's not fine. What am I talking about? Yeah, it needs to be float. Do I cast the X and the whatever? Oh, there we go. Yeah, look at that. Gorgeous. Now I've just got to make it so that the black ones don't get drawn because they're not actually supposed to be there. It's supposed to be air. So we just say, I guess, yeah, we'll just leave it like that. And we'll say, maybe not. Maybe we say 0.5 times this value, which will be 0 if it's 0. Ooh, baby, look at that. That does not look great. I think maybe the alpha is looking... I think I messed up the blending there. Let's see if we just use a solid color. No. Oh, is it the culling? Could be the culling. Or maybe I'm drawing them backwards. Let's see. Culling. We're culling the back. I'm just going to not cull for now. No, that's still not the problem. Is it the right pipeline? Yeah. What if I disable blending now? Get out of here. We don't want blending. Nobody wants blending. Ah, now I can't do alpha. So... that's actually a bit of a problem, isn't it? Going back to the fragment shader, if I do something really silly, is it gonna totally look wrong? Like, for example, if we just put this in a variable here, like voxel value or something, or just v, right? If v is less than 1, discard. See, I got a feeling that's going to not work because, well, I'll try it first and then we'll see. Oh no, it does work. I thought if I was looking at something from the front with a discarded pixel that it wouldn't draw the block behind it, but it does seem to work. So, awesome. This is basically what I wanted to do today, and we're just a little bit over time, so I think that's great. It's a good stopping point. So cool. Amazing. Now, I think this is going to be much, much, much more performant. And also, it offers us a really nice way of having data that we can use on the CPU and on the GPU side as a 3D texture. That's really cool. So what I'm going to plan to do in the future is, instead of just sending 0 and 255, we're actually going to send in the distance to the nearest voxel. So if we've got, for example, let's say this one is filled in, okay, and let's just use 2D for this example. So this one's filled in, and we're here. Maybe we'll just do this one. We're down here. So these are all air. Let's say this is the nearest solid voxel. We're actually going to send in the number 2, or maybe 3, 2, and 1. And then inside a voxel will be -1. So this will actually be -1, or inside a voxel will be 4 bits for the material ID. And then 4 bits for maybe the shape if we have slopes and stuff, because we're going to do that eventually. Something like this. And then if, for example, this one was solid as well, so let's say these two are solid here, right? So this one here, we might do something like, since it's inside, actually maybe I'll make it more inside. Just bear with me for just a second. Can't do it there. Let's say these are all filled in, and we're going to get the value of this one. So actually it would be the same, material shape, material ID and shape, but I kind of want to add a little bit more information. So the idea of adding the number 1, 2, and 3 is that if we want to render this with ray marching, we can sample the voxel grid at any point, and it will tell us, hey, if we're shooting a ray like up here, and we hit, we're starting in this voxel here, and it's the number 6, then we know we can move, and let's say we're going straight up, right? We know we can move 6 voxels without hitting anything. So that gives us way better performance than if we were moving like 1 voxel at a time to do ray marching, for example. So that's kind of the idea that I'm getting at. So hopefully next time we can render the same cube, the same chunk, but instead of using rasterization like this, which is just drawing the vertices, we're going to use ray marching and draw these this chunk as a big ray marched signed distance field. So that's sort of the next step. So yeah, I think, well, I hope that we've got a lot of those memory issues are solved by just deleting those thousands of lines of code. And everything's a lot simpler now, which is nice. The cool thing about ray marching is I'll show you what I did yesterday. So I've been doing some study. I've been doing a couple of different courses and things in my when I have time at night, if possible. And so if we look at this shader toy example here, I'm going to turn off the shadows. So you can see the code for this is just like, well, it's tiny probably. Let me make this much larger for you. The code for this whole scene is just 150 lines in a fragment shader. There's no vertices. There's nothing crazy going on. And if we turn off, for example, the lighting here, I'm just going to comment out this and delete this. You can see we get, actually not the lighting. I wanted to turn off the shadows, not the lighting, because I want to show you the ambient occlusion. See those little shadows there below the boxes? I'll make it a bit bigger. It's got really nice ambient occlusion, and it's really easy. It's like, whereas the code here, it's this code, which is just nuts. So yeah, I'm excited to see if we can render our cubes using ray marching, because then we get a lot of interesting benefits. So yeah, that's it for this one, and thanks for tuning in, and